Hello everyone, and welcome to our Intro to Object-Oriented Programming class. This is actually lesson 5. That's a typo right there. Let me fix that. Lesson 5 of our Java series. And if people are joining via watching this video on YouTube after it's posted to or after the event, lesson 4 we did not record because it was just kind of review and practice. There was no new material to learn. But today we're going to start on objects and classes. This is the kind of core of what makes Java Java. So without any further ado, we'll get started. Today what we're going to cover are what are classes and objects, basically what is this stuff and why does it exist. We'll go over what is a constructor, and access modifiers, getters and setters, and packages. A lot of this is going to sound like nonsense to you right now, but I promise you by the end of this, you will have some understanding of what each of these things are and how to use them in your program. Any questions before we get started? Don't forget to unmute if you do have a question. Cool. Also, I recommend a headset to prevent echo. All right, let's move forward. So what are classes and objects? So I actually probably am missing a slide here. First, we should probably ask, what is object-oriented programming? In software, we often use software to describe the real world, right? So you might have like an HR application where you might have things like employees and departments and payroll and all these kinds of things that you want to represent as software to do work for you. Computers do work for us so we can get more work done faster, right? And modeling the real world as objects in code is how we do this in software design and development. So how do we do object-oriented programming? We do this using classes and objects. Classes you can think of like a blueprint, which is why I have these images here. It defines kind of what an object looks like, how it operates, the shape of it, all these kinds of things. And then the object itself is created based on the blueprint, but each object can be slightly different, right? They all still match the blueprint, but the blueprint allows for a little bit of change within some constraints. Okay? So a class defines kind of the structure and the behavior. The object is built from that definition of structure and behavior and is an actual thing. So a class is like an idea, an object is like a thing. Okay? This, at the beginning, when I explain this to you now, you're like, oh, okay, sure. But as time goes on, this may be a little bit difficult to understand, which is why I'm focusing on this so heavily. So if this doesn't make sense to you, please tell me. It's important that you understand this concept first. Okay? So one more time, classes are kind of the blueprint for how something should behave and should be set up. And then the object is created based on that blueprint, and you can do stuff with it. Okay? So far, so good? Cool. All right. So now what are these in kind of more detail? Objects take related variables and functions and put them together into one kind of package. Okay. So you can take a whole bunch of variables that you define, a whole bunch of functions that you can define, and you can package them all into one thing. And then you can move that thing around with its variables and functions as one, let's call it package. Okay. As I mentioned before, programming often models the real world. So objects should, albeit imperfectly, mimic reality, okay? So if I have some object that is like a mouse, okay, this mouse will model, or my mouse in code will model this mouse somehow. It may have something like a weight, or a size, or a color, whether it's wired or not, these kinds of things, okay? And those are the kinds of things we would define as part of the object. Now, objects know things, that is, they store data as variables, and they do things. They do actions or execute code as functions. Okay, so they know things as variables and do things as functions. Okay, these are the two core principles of an object. And then the functions can do work with the data inside the object. Okay, and in objects, we kind of use slightly different terms. When it comes to objects specifically, instead of calling variables variables, you'll often hear us say properties. Okay? The only difference between a variable and a property is that a property is inside an object. Other than that, they're the same thing. And sometimes we'll also call properties as variables. We can switch the terms. Property just means it's inside an object. And then functions has a similar thing, where a function inside an object, we call it a method. And like I said, we'll sometimes switch between the two. Sometimes we'll call it a function, sometimes we'll call it a method. They're really the same thing, except a method is only in an object. A function can be anywhere. Questions so far? Cool. And classes, the reason they're called classes is because they're a classification of objects, not classes in like a lesson. A class is in a classification. So the class defines the data, basically the variables or properties, and functions or methods that an object has inside it. Okay, so again, the class is like the blueprint. It says what data the object can store and what functions the object can do. Okay, the class defines what the object knows and what the object can do. And from the class, again, like the blueprint, you can create many objects from the same class. Okay, so if I have a building class, I can create many building objects based on that class. So far, so good? Cool. I'm really worried because I know that at some point I'm going to lose all of you. So because this stuff is really tricky to teach, so I'm going to ask for confirmation a lot. All right, moving forward. So now so previously when we defined variables, we had to specify the data type, right? So is it an integer? Is it a float? Is it a Boolean? All right. Those were primitive types. Classes are another type. So when you define a new variable, right? Let's say I make a building class, and let's say I want to create a new variable with the name my first building. I can specify its type as building, as the name of the class. And in that way, I say this variable can store a building object inside of it. Okay. And then this is a little bit of vocabulary because you might be asked this stuff in kind of like a job interview. So when I said earlier that an object knows things and does things, right? It has its own variables. The variables in that object are separate from the variables of any other object, right? So if you change something here, right? If you change something in one variable, in the other variable, if you change a variable in one object, it's not going to affect the same variable in a different object. They are separate. We call this concept encapsulation. That is, each object encapsulates or basically contains its data separately from other data. Okay? We call that concept encapsulation. Or if you want to practice your Korean, it's encapsulhwa. And then you don't necessarily need to know how everything inside an object works if you're using an object from somewhere else. You only need to know kind of the variables it makes available to you and the functions it exposes to you, because some of those can be hidden. And the fact that some of these things can be hidden and you only see the inputs and outputs, we call this concept abstraction. But we'll talk about abstraction a little bit more later, so don't worry too much if you don't understand that part yet. Okay? So again, to review, when you're creating a new object, you can store it in a variable whose type is the name of the class. and each object will have data separate from any other object. Questions so far? Okay, cool, because this is often the point where I start to lose people, so. Okay, let's see how this goes. So, in the presentation on the left side, we have defining a new class. Now, we've kind of done this already in previous lessons, where we define a class and then we have a main method. But in this case, we can define other methods, kind of like we've been doing before a little bit. But we can also define, I don't know if you can see my mouse here, but we can also define variables within the class. Now, this is a property, okay? And this can be used inside the class. So again, this is a class definition. This is like the blueprint. And then on the right side, we create objects from that class. So if we look at this first one here, we're creating a new variable called myNewCar, and we're saying that its data type, or the data it can store, is a car, the car class, okay? And then we assign it to a car object. The way we create an object from a class is we use this new keyword, and then we do the name of the class, and then parentheses. We'll cover exactly what this means in a second, okay? But creating an object from a class is new, the name of the class, and then the parentheses. And then you can store that in some variable. So far, so good? Cool. So let's, whoa, where am I? Okay. So let's actually, just to kind of get things going, kind of practicing while we're doing things, let's go ahead and open up Intellij, if you guys have it installed already. We're going to start writing code using this as an example. So in Intellij, you should see a window like this when you first open it up. I hope this is what you're seeing. I cannot see what I'm presenting to you. So on the screen, do you see the Intellij welcome screen that I'm presenting? Okay, great. So here you want to click New Project. And it might be a little slow. You're going to see all of this junk. You don't need to worry about it yet, okay? All you need to worry about is just hitting next. The rest of the stuff you'll use in more advanced Java classes. For our basic stuff, just ignore this, just hit next. Ignore create project from template and give your project a name. Hold up, I'm going to change my directory here because I have a project directory that I tend to use for everything. Actually, no, because this is for CodeSeoul, so I use a different folder for that. Sorry, allow me a moment. Documents, I believe. Oh, I guess not. Jeez. Nope. Oh, intro Java. There we go. Oh, that's lovely. All right, maybe it's in here. Yeah, there we go. Okay, Java. Cool, here we go. And I'm going to make a new project folder called 05 classes and objects. Cool. But you guys can call it whatever you want and place it wherever you want. Why is it not liking this? Oh. Okay. Is that okay? Is it going to complain? Yes, create the directory. Okay. Now, you should get a message like this, directory does not exist. It will ask you if you want to create it. You can go ahead and say, okay. And then it should look like this. Does everyone have a screen like this at this point? If you're using Intellij or some equivalent in Eclipse? Cool. How about you, Bobo Nazar and Catherine? You guys? Okay, great. If you're using Eclipse, you can feel free to ask me for help. I haven't used Eclipse in like 10 years. So I don't know how much help I'll be, but I'll try. Okay, great. Okay, perfect. Okay, great. So now if you're using Intellij, you want to open up your project pane here, and you'll see your files. This is very similar to Visual Studio Code. And then you'll see your project name up here. You'll also see external libraries and scratches and consoles. Generally, you can ignore that. When we do the more advanced Java class, we'll cover these things, but you can ignore it for now. So expand your project folder, and you should see this src directory. Okay, that's our source folder. That's where we store our Java files. So I'm going to right-click this, and I imagine it's similar in Eclipse. I'm going to right-click this and do New Java Class. And we're going to do the same thing I did in our presentation here. I'm going to create a new class called car. And then select class and just hit enter. And it'll create a new file named car.java. And it'll create it in the source directory. And it'll actually create this public class part for me. And at this point, let's rearrange my window up here so we can see both. Can you guys see the text on IntelliJ for me, or is it too small? Zoom in? Okay. One person can see it, one person wants to zoom in, so I will zoom in. Editor, font, let's make it 18. No, let's make it 24. Yeah. All right, is that better? Great. So now I'm going to type the same thing in here that I have in the presentation. Oh. Hey there, Alex. Welcome to the party. Not too bad. We're just setting up our first, not our first class, but the first class we're going to use like a class. Okay. And then what I want you guys to do is actually make a second class, if that's okay. Oh, actually, you know what? Let's not do that yet. Just leave this as is. So you should see this, and we can't really run this yet. It won't do anything. But I just want you guys to have some code so that we can build on it later. Okay? Questions about this before we move on? Or do people need more time to type? Cool. Let me know when you're ready. Okay, great. All right, so now we're going to go back to the presentation and move on. So to kind of review what we've gone over here, again, the class defines the structure of objects, okay? And each object will contain separate data, okay? So if we go back here, whoops, my new car and another car store two separate objects. They're both car objects. They're both built from the car class, but they're going to have separate data, okay? And each object will behave the same way. That is, they will have the same functions. So both my new car and another car will have this drive method here. Okay, they'll both have that, and it will do the same thing. And now, doing work on one object won't affect another object. So if I change something in my new car, it's not going to affect another car. Okay? There are some exceptions to this, but we're going to cover that way later, so don't worry about that for now. For now, consider that true. And again, this is encapsulation. Doing things to one object won't affect another object, okay? Questions on that so far? Oh man, I'm the longer that I go without losing you guys, the more I'm worried about how bad it's going to be. All right, so Okay, we're not covering abstract data types. We're doing that in a later class. This is the idea of abstraction, not abstract classes. These are two different things, unfortunately. The naming's not very good. Yeah, abstract classes are going to be in lesson, I think, 8 out of 9. This is lesson 5. Abstraction is going to be in, abstraction is going to be in lesson 8. So yeah, all right. So far so good then? Cool. All right, I'm going to move forward. So earlier I mentioned, let's get the right screen. There we go. Earlier I mentioned constructor. We're going to cover that now. Constructors are special methods that are run, the code inside them is run when you create a new object from a class. So remember when we did this new car right here? When we do this, the constructor does whatever you define inside it. The constructor is executed, it runs its code. Okay? The constructor's name is the same name as its class. So for the car class, the constructor's name, the special method, is also going to be called car. And the constructor doesn't specify its output type. Remember in the past, when we defined other functions, we had to specify void or int or string or whatever, right? We had to specify its output. Constructors, you don't have to do that because it's going to output the new object. So it already knows what you're going to do. Constructors also don't use return, again, because they're going to output the object that's being constructed. Okay, so this is what makes a constructor different from other functions. Questions about that so far? Cool. So having an example of a constructor, this is the same code as before, but we've added this constructor method here in the middle. So you'll notice the name of the method is car. And in this case, I've had this function, this method, take in one parameter. Oh, there's actually a bug here, sorry. There we go. It takes in one parameter. That's an integer that we're going to call count wheels. Okay? And this is an input to the constructor function. And then remember this num wheels variable that we defined inside the car earlier? We're going to take that parameter, and we're going to take whatever value is given to it, and we're going to store it in the object's num wheels property. All right? We're using the keyword this. This is a special word in Java, and this means basically the current object. So the newly constructed object, the object that we're building now is this keyword. And then to access this variable on the object, we use this dot and then the name of the variable, the name of the property. And we're going to set the value of that to whatever the value of count wheels is. So if you remember functions well from past classes, then this should be a little bit straightforward. This part is kind of new. But otherwise it should be straightforward. Let's go ahead and let's go back to our development environment for a moment, and let's add this constructor. Yes. Good question. So when we call, you know what, let me skip ahead to answer your question. Let's do I not? Oh, I waited way too long for the example. Okay. Right, because I wanted to do imports. Okay, so we have this constructor, right? This constructor takes in an input. We have this dot num wheels, right? Oh, oh, perfect. So if I'm creating a new car variable, right? My new car, all right, is a variable of car data type, and I'm doing new to create a new object. When I create this new car object, remember this is executing the constructor, right? That's what we said previously. And I'm passing in the number 4 as a parameter. So what happens is, in our constructor function, count wheels gets set to 4. Okay, so count wheels is now 4. And then the new object's num wheels property gets set to that number 4. Do I have any sort of drawing? Oh, I do. Oh, I can't draw with it. Really? Really, Google? I'm disappointed. Okay, I can't draw with it. But I'm going to use the hell out of this pointer. So this gets the number 4, right? Count wheels is the number 4. And then num wheels will then store that number 4. Now, that number 4 is only going to be for the my new car object. Okay? So if I create a second object, that one, if I set its num wheels to 6, this one's num wheels is going to be 6. This one's num wheels is going to be 4, and they're going to be different. Okay? Because this is referring to a different object. Does that answer your question? Oh, okay. That was the first scary one. Yeah. So let's go ahead and get this typed up in our car class here. So back in our development environment, let's go ahead and create this constructor. So move this a little bit more to the right. Oh, yeah. Okay. Okay. So everyone should have something like this, and let me know when you've got it typed out. Ooh, the nice part too is I think your questions get recorded in the recording too. So that's really cool. Oh, on that note, if anyone does not want their voice to appear in the recording or their name to appear in the recording, please tell me and I will edit it out before posting. Okay? Cool. I apologize for not letting you guys know about the name and voice thing in the recording earlier. And Kasan and Bobonazar, please let me know when you guys... Huh? Cool. Kasan too? All right, great. Let's move forward. So answering your question, we kind of went over this slide already. Each object contains its own data. Again, this is the concept of encapsulation. Setting the data for one object will not affect another object. They are completely separate. So if we were to run this code, which we will do something like this later, if we do my new car dot num wheels, dot allows us to access the properties and functions of that object, the properties and methods of that object. Num wheels in this case will be 4. Down here, another car is going to be a new object, a separate object. We're going to set its num wheels as 6. And so this will print out another car has 6. Okay. Notice again, all of these objects have the same property. Okay, because they all come from the same class. Remember, the class defines the structure. The object can have different data fitting that structure. But because these are separate objects, my new car, another car, third car, They'll have the same structure, but the data in that structure will be different. My new car has 4 as its number of wheels. Another car has 6 as its number of wheels. Third car has 8 as its number of wheels. And all of these are completely separate and independent from one another. And again, this is called encapsulation. Questions about this? Cool. All right. Oh, encapsulation is down. That's good. Okay. Now, we defined this num wheels, and we used it in these print statements here. But it's also worth noting, you can still use this data inside the class. So in our drive method, we can actually use the number of wheels to tell the user how we're driving. So let's actually go ahead and in the car that we're coding up right now, let's go ahead and add that. I'm going to make this a little bit wider. So in our drive function, I'm going to change this text here. I'm going to say, I'm driving on. I'm actually going to add a new line here. You don't have to add this new line. I'm just doing it so it all fits in one page for you guys. You don't have to add the new line. All right. And in this way, we're referencing the same num wheels property that's being set here. These are all the same. Now you'll see in Intellij how num wheels is highlighted in all 3 locations. That's just Intellij being helpful and telling me that these are all the same variable, the same property, the same data. Okay. So let me know when you guys have that updated. Actually, let me go ahead and remove this new line since I can make this big. Cool. Great. Good. All right, so let's move forward. So that defines constructors. That allows us to set the properties of the object or anything else really. We can put any code in here, but allows us to do stuff when the object is created. Okay. So next up is access modifiers. Access modifiers also kind of support the idea of encapsulation, but this, you mentioned earlier abstraction. Access modifiers kind of help more with abstraction, and we're going to explain why in a second. So access modifiers control what a programmer can and cannot access on an object. Okay, so I can create a property and I can say this property can only be used inside the class. You can't use it from outside the class, right? The same with a method, okay? A beginner habit is to make everything public. Just because if everything's public, you can always access everything, no problem. Don't do this, okay? Public just means anyone and anything can access it at any time, and everything's just super easy to mess with. And it sounds like that's going to make your life easier, but I promise you it won't. Access modifiers can be helpful with things like code completion. So if you can see something on an object, your development environment, IntelliJ, Eclipse, whatever, will basically show you what you can access. And if you can't access some property or method, it won't show you. And that just makes life easier. And as I said before, access modifiers help you with abstractions. So they help you, either your future self later, or someone else, know which data they can and can't mess with. Okay? So you're like, okay, but why is the question that people often ask. And it's basically because you can think of access modifiers as kind of helping with the instruction manual, right? Like if you're building IKEA furniture, for example, you don't necessarily want that was maybe not a good example. So in an IKEA furniture, for example, if you're building a table, right, the wood has kind of a finish on the outside, right? And that prevents you from getting to the wood on the inside because they don't want you messing with that. They don't want you to like break the wood and dig out the insides, right? That doesn't help you. You don't want to do that. But this is maybe a terrible example. But basically, private would say, hey, the wood on the inside, you shouldn't touch that. Basically, you can't access this. But public is like when there's a hole in the table for a screw to go in. Oh, okay, that's you should be accessing this part. This is the part I want you to mess with. That was maybe a crap example, but we'll come up with better ones as we progress. Now this this table will be more useful to you later. For now, I only want you to worry about public and private. Everything else, don't worry about it too much. We're going to cover it later. Right now, just focus on private and public. Private basically means only this class can access it, and public means anything can access it. Okay, and we won't use all this today. Just focus on public and private for now. But later, you can use this as a reference. I know I'm not giving the chance for questions here. It's because this part we need to go through fully before it can really be understood well. Now, for example, if I have this, if I have the num wheels property and I mark it as public, and then in some other class I say my car.num wheels, right? No problem. This is public. I can access it from the outside. However, if I set num wheels to private, if I use this private keyword in front of the num wheels property, then this will give me an error. Okay, because in another class, I can't access this. This will not work. Okay. Questions about this so far? Now that I've finally hit this point? I'm worried this is where I may have lost people. Really? All right, cool. Okay. Huh. Yeah. I think once we get into the more interactive coding, that's when more of the questions will come up, and that's okay. So let's go ahead and actually no. Let's move forward for now. Access modifiers are a little tricky to understand until this next section, getters and setters. You want to control access to the properties of a class in order to protect other programmers, or maybe even yourself later, from using the object improperly, right? So maybe the number of wheels should just be something that the object knows internally, but it doesn't need to expose it to the whole world, right? That the whole world can just, it's like using the car as an example. If anyone could just like, oh, let me just take off 2 wheels of the car, like that's not good, right? If you want to remove wheels from the car, there's some special work that you need to do, right? Or if you want to add more wheels to the car, there's some extra work that you need to do. So letting people just add and remove wheels whenever they want is not going to be a good time, and it's just going to hurt whomever is using the car, right? So access modifiers kind of help us say, hey, the number of wheels is private. This is something you shouldn't mess with, but the car still needs to know it. So it's going to track it internally. That's a much better example. I hope that does that make more sense for you guys? Okay, cool. So when using the wheels thing as an example, getters and setters allow us to share information about the wheels without allowing the user to just do anything they want with them, right? So for example, if we have num wheels as private, but we still want the user to know the number of wheels there are, we can create something called a getter. A getter is a method that will return the value of the object, right? So we can create a method called getWheels, and it will just output the number of wheels. And if we only have that getter, that allows someone using our car object to see the number of wheels. But if the number of wheels is still private, they can't change it. So they can look, but they can't touch, if that makes sense. And then on the other side, there are setters, which are methods that allow you to change the value of a property. And you may be thinking, well, if you define a getter and a setter, then why not just make it public? The reason is that maybe when you change an object's properties, you want some sort of side effect to happen, right? Like if you add more wheels to the car, right? Maybe it should also add a new axle to the car, for example. And that would be a side effect, right? But if you just allow them to modify the wheels directly, you don't have the chance to add the axle to the car for them, right? But having a setter method allows you to update the number of wheels for them and do the extra work of adding the axle to the car, for example. Or maybe if they add some weird thing like an odd number of wheels, maybe you can throw an error, right? Be like, hey, you can't do that, sort of thing. Does that make sense to you guys so far? This one's a little bit harder to understand, maybe. All right. I expect a whole bunch of questions to come up when we start coding, and that's okay. Now, when I talk about these getters and setters, these aren't built-in things to Java. Java doesn't know about these. These are just strategies that Java programmers use, okay? It's not a built-into Java. It's just something that people often do because it's a good idea. And we'll demonstrate this in a little bit. So here is an example getter, this get num wheels, and an example setter, set num wheels. Okay, so let's go ahead and back in our code here. Let's go ahead and add these methods. So int get num wheels. Oh, nice. Actually, you know what? I'm gonna show you guys a trick. And I believe you can do this in Eclipse too, though I'm not sure exactly how. So in Intellij, if you click code and you go to generate, it gives you this menu here of options. And you can choose getter and setter. And you can say, hey, I want to generate getter and setter methods for the num wheels property. And you can just hit OK. And it writes the code for you. Super easy. And I'm pretty confident there's a similar function in Eclipse. I just don't know it off the top of my head. And I believe these will be the same in both the example and the code we have here. Yeah, these are the same, except they made these public. Oh, right. So sorry, let's make these public. And let's also make our num wheels private, and let's make our constructor public. And let me change that to presentation as well. Sorry, let me get this fixed up for you guys, and then I can show you everything. Sorry. Lowercase p. Okay, so make your class look something like this. Crap, I don't have enough space on my screen. Maybe we'll do this. There we go. Yeah, not enough space on my screen. Okay, so go ahead and get this typed out, and let me know when you guys have it finished. Okay, great. Okay. All right, great. Okay, so far so good. So that's getters and setters. And if you don't understand this part 100% yet, it'll probably make more sense once we start doing more coding interactively, and we're doing excellent on time. So that's getters and setters. Again, getters allow you to mark a property as private. Where's my pointer? Allow you to mark a property as private and make it accessible via a public method that just outputs the property. Okay. And then a setter allows you to set the property also using a method instead of setting it directly. And that allows you to do interesting things like add logging or do any extra work that you need to do. And we call these side effects. All right. So that's getters and setters. And we're going to move forward. Packages. Okay. This is the last part we need before we can, before we can actually do more interactive coding. Packages are ways to group your classes. Because in large projects, you're going to have hundreds of classes. Like, no joke, there's going to be hundreds of them. It's going to be really confusing and messy, but packages help you manage that. So you can have like 10 packages here, 5 packages here, or I'm sorry, 10 classes in one package, 5 classes in another package. Packages are just ways to group classes. And you can have packages inside packages. Okay. Now, what are packages like in your project? They're just folders. Like a package is a folder. That's it. It's just a folder. But if you want to access stuff via packages in your code, you just use the folder name as the package name, and then if you want to go to the folder inside that, use a dot in between. So if I have like a folder A, or a package A, which is just a folder, that's also going to have the name A. All right, and then inside it, I have another folder, B, and I want to access something inside folder B, I just do A.B. Okay. And then packages, you need packages when you're importing classes. So when I say importing, one class can use another class, and we're going to demonstrate that in a second. And you need packages in order to do this. And finally, when creating your packages, when creating your folders, there's a common way to do it. Again, this is not required. This is not something Java enforces. It's just how we usually do things. It's the common practice. It's reverse domain name. So if you're working for a company like mycompany.com, it's going to be backwards. So your packages will be com my company, and that's just convention. So using CodeSeoul as an example, if we were building something for the website of CodeSeoul, the www of CodeSeoul, and the website was www.codeseoul.org, our package structure would be we'd have a folder named org, and then inside it we'd have a folder named CodeSeoul, and then inside it we'd have a folder named www. Does that make sense to everyone? Cool. So to give an example, on the left side here, we have one class. Actually, I should fix this. Yeah, I'm going to fix this afterwards. Where we have some folder org, some folder CodeSeoul, some folder Java, some folder vehicles, and then inside that we have our car.java class. And then at the top of our class, we have to tell the class which package it belongs to. So we just say package org dot instead of slash CodeSeoul dot instead of slash Java dot vehicles. And this is just the same thing as up here, okay? And then we might have a separate class, right? A main class that's just in the Java package instead of the vehicles package. But then if we want to use our car class inside our main class, we have to import it. This is what importing is. It's basically taking code from another file and using it in this file. That's what import is. But when you do an import, you have to specify the name of the package. So we do import org.codeseoul.java.vehicles.car. And now we can use the car class in this class. So this is literally just telling Java, where do I find the class file for this? That's all it is. Does that make sense? The package is the folder. Packages and folders are the same thing. So yeah. So I have some org folder. Inside that org folder, I have a CodeSeoul folder. Inside that inside that CodeSeoul folder, I have another folder called Java. Inside that, I have another folder called Vehicles. And then inside Vehicles, I have a file called car.java. And then the package just matches that. Correct. Yep. It's a Java thing. Yep. So let's go ahead and try this. Let's go to our development environment. I'm going to open up this project pane again. And we have the source directory where we're putting our code. I think Eclipse has a similar thing. What I'm going to do here is I'm going to right click. I'm going to do new package. Now the nice thing about something like Intellij or Eclipse is that instead of having to create each individual folder, that's a mess. Instead, what I can just do is org.codeseoul.java.vehicles. And if I do it this way, if I separate them with dots, Intellij or Eclipse will automatically create the folders for me. So now I just hit enter. And you'll see in the project pane, it just says org.codeseoul.java.vehicles. However, if I look at this on my file system, if I can find the button, where is the button? I know there's a button. Open in Explorer. There we go. So here's my project directory on my file system. I have this source folder, and now you'll see org, and inside org is CodeSeoul, and inside CodeSeoul is Java, and inside Java is vehicles. That's it. They're just folders inside folders, separated by dots. Is that a little clearer for you guys? Cool. So now what I'm going to do is to match what I have here, I'm going to take this car class, and this, again, should work in both Intellij and Eclipse. I'm going to click and drag it into this package. And it's going to say, hey, are you sure you want to do this? Yes, I want to do this. Now, cool thing, Intellij added the package at the top. And Eclipse will do the same thing. So it did this for you. You don't have to worry about it. So far, so good? Cool. If you get stuck, or if something seems wrong, please tell me. I am here to help you. Just package. We're going to do import next, just one step at a time. Eventually we'll do that, but for now we're just saying, hey, this car class is inside this package. That's all we're doing for now. We're going to do import after this. Cool. I know the project pane is probably a little bit small for you, but does it look like this? Great. Okay, then you're good. How about you, Bobo? How about you guys, Kasan and Bobozar? Are you guys okay? Are you up to this point? Okay, tell me. the other way around. But you should be able to create a new package, and then, oh, someone joining us late. Hello, Mohammed. You're a bit late, and I can't hear you if you're talking. You are muted. But we'll try to get you caught up once I solve some problems we have here. Okay. So Kasan, you should have created a series of packages here, and then inside that you needed to move your car class. Alternatively, can you in Meet present your screen and I can see what your thing looks like and we can fix it up? And don't worry, I'm not going to put your your screen in the recording because I don't want people's full names to be published. Okay. I can see it. Okay, so it looks like I see. Okay. So go ahead and remove line 2. In your class, yeah, remove line 2. There you go. And then let's see. In the Project Explorer on the left side, your CodeSeoul Lesson 5 package, go ahead and expand that. Click the little arrow next to it. There you go. Now select car.java. And can you make the Project Explorer a little bit bigger? Can you drag the right edge of that to the right a little more so we can see it? No, sorry, the Project Explorer, because I can't see the right edge. So if you put your mouse between the, yeah, there we go. Cool. Okay, go ahead and drag car.java. If you click and drag that over org.codeseoul.java. Yep, and yep, and hit OK. Done. There you go. Now it updated package at the top for you. Do you see that? Now it says package org.codeseoul.java. Correct. Cool. All right. Good job. So I'm going to take back presentation. How do I do this? Oh, I don't need to. Resume my presentation. Yes. Okay, great. So that's one thing. And now we're going to create a second class. So what I'm going to do is I'm going to right click my source folder. I'm going to click new, and then I'm going to go to Java class. And because of the way I have this, I want to put this in a folder above vehicles. So it's a little difficult. I'm going to specify the full package name for this new class. I'm going to do org.codeseoul.java.main with a capital M as my class. And what this will do is Intellij, and I'm pretty confident Eclipse will do this too, is it'll create this new main class file, this new main Java file, and it'll put it in the correct folder for you. Okay, so if you just type like this, and then hit enter, you'll see that it's separated the, oh, I typed it wrong. Oh, I suck. Okay, hold up. Crap, I messed up. Well, now you get to see how to fix it if you mess up. So I'm going to right click main because I did it in the wrong place. I'm going to go to refactor. I'm going to go to move class. It's not CodeSeoul, it's CodeSeoul. I'm going to refactor. Okay. And I'm going to delete this other package. Okay, there we go. So now you'll see org.codeseoul.java. I have my main class, and then I have the other vehicles package inside that. And it just works like a folder. Does everyone have something like this? Okay. So right-click src, new Java class, and then do org.codeseoul.java.main with a capital M. And then if you hit enter, it should create the new file in the correct directory. It's actually not in the vehicles folder, it's in the Java folder. Cool. All right. While you guys are figuring that out, Mohammed, you have a lot to catch up on. Do you have Intellij or Eclipse installed already, Mohammed? You are muted, so I cannot hear you if you're answering me. You would need to click unmute. Hey, good to hear from you. We are not Sorry? Yeah, this is just plain Java. We're not using Maven. Yeah, it's just okay. Eclipse, great. So in your project explorer on the left side in Eclipse, in your source directory, you want to right click, do new package, and do org.codeseoul.java.vehicles, and then you want to create this this car class inside here, and you want to basically type out all this. You know what? How about this? I'm going to save you some time, and in the chat of Meet, I'm just going to send it. There we go, and you can just copy that into your car class file. However, due to time constraints, it may be best to just kind of watch for now and try to catch up when you can, because we still have 40 minutes left, but it's going to take a little bit to get all this stuff done. So I'm not going to have a whole lot of time to help you catch up. So ask questions if something's broken. But other than that, I'm going to need you to try to catch up on your own, okay? All right, so back to, you guys should have created your main class, and it should appear under the org.codeseoul.java package. And it should look like this. It should look very similar in both Intellij and Eclipse. And now we want to, if we look at our example here, our example is actually slightly wrong. I apologize. Let me shrink this a little bit. Sorry, give me a moment. There we go. If we look at our example on the right side of my screen here, we want to use our car, right? However, our car is in a different file. So in order to access it, we need to import. And so what we're going to do here is after our package definition at the top of our file, we're going to do import org dot, and you'll see it will autocomplete for us, CodeSeoul.java dot vehicles dot car. Done. A lot of people say Java is just typing a letter and then hitting enter a bunch of times. This is a demonstration of that. And don't forget your semicolon at the end. And now by doing this, once we've added this line here, this allows us to use car inside of this class. So we're using another class inside of our main class. Now, once you have that added, inside your main class, if you just start typing main, it'll allow you to autocomplete the creation of your main method. So you can just type main, you'll see this auto-completion come up. I believe it's the same in Eclipse, but I'm not 100% sure. You just hit enter, and it'll generate your main function for you. And then you can add this code here. I'm actually going to edit the presentation real quick because the presentation is not correct. Crap, I may not have enough space for this. Crap. Yep. Ah, crap. All right, I'm gonna have to fix up the presentation later because the presentation is all sorts of messed up now. But I will fix this after class. So let's make a, let's just go ahead and do my new car equals new car and car, another car, then car, third car. Okay, so let's go ahead and make your code look like this. And so basically get this typed up. Let me know when you guys are done typing, and then we will experiment with this, and you guys can see how everything kind of works together. Because I know it's been a lot of theory and not a whole lot of practice. Now we're going to do the practice. So let me know when you got this typed up. While people are typing, Mohammed, do you have any questions or trouble? Let's actually do this. There we go. Okay. Okay, great. Excellent. Yes, the package is org.codeseoul.java.vehicles. Yeah, the vehicles package is beneath the Java package. Yeah. Okay, can you present your screen so I can troubleshoot it for you? All right, let me see what you got here. Oh, damn. I apologize, Catherine. So, for people who are on the recording, Intellij is too helpful. So this gray text here, you see this count wheels colon before the number 4? That's not actually there. I did not type that. That text is not in the file. That is Intellij adding this text to kind of remind me that the name of this parameter is count wheels. It's not actually in the text here. I wonder if there's a way I can hide that. But it would take me too much time to figure out right now. But in your file, you'll notice I can't actually highlight this text because it doesn't actually exist. Yeah, so if you remove that count wheels colon, it should work. Oh, disable hints. Hey, there we go. Okay, cool. It should look like this. There you go. Yeah. I right-clicked and disabled hints. You only need to type this part. You'll see the gray text. Wait, how do I show the hint again? Maybe undo? Nope. Well, okay. Looks like that was a one-way operation. Yeah, so you'll see some gray text here that says count wheels colon and then the number 4. But that text is not really there. Intellij is just showing that to help remind you. So in your lines 9 and 11, if you just remove the count wheels colon, it should be fine. How do I get the hint back? I don't want the hints. Screw it. So yours will now look slightly different because I turned off hints. But don't worry, what you have right now is correct. All right. Does anyone else have any questions or any problems? Sorry, get my screen back presenting here. Has everyone got this part typed up, their main class? Kazan and Bobonazar? Okay, sounds good. Let me see if I can, no, there's not enough screen for that. Maybe if I do this. Yeah, there we go. Okay, great. Oh, you're fast. Okay. Gotcha. Okay, great. Oh, okay. Cool. All right, great. Okay, sorry about that. All right, so at this point, this is kind of like the baseline. And I'm going to review what we have so far, and then we're going to experiment and show how all this stuff interacts. Okay? So, and this is going to take the remaining 30 minutes, because this stuff is a little bit difficult to understand, and yeah, okay. Girlfriend needs to stop messaging me. Cool. She knows I'm in class. She just doesn't know that the pop-ups happen. So, explaining, right? So, we have this org.codeseoul.java package. Again, it's an org folder with a CodeSeoul folder inside it with a Java folder inside it. And then this main.java file exists inside there. So if I do open in Explorer, you'll see, if you look at my address bar up top here, you'll see source, my source directory, org is one folder, CodeSeoul is another folder, Java is another folder, and main.java is inside of that. Additionally, I have this vehicles package inside the Java package. So that's just another folder inside this folder. And inside there, I have car.java. Okay? Everyone understands that much so far, right? Great. Then, at the top of each of these files, I have to tell them which package they're in, and it should match the folders. For example, if I change this to blah, it's going to complain. It's going to be like, what the hell is this? That's not the folder I'm inside. What are you doing, you madman? So it should match. Okay. Now that we have this car class inside our vehicles package, that basically serves as the package plus the class name basically tell Java where this file is so that I can use the code from there inside a separate class. So the separate class is our main class here. And I'm going to import car, specifying its package, followed by car, again separated with dots. Okay. Now, you guys already know how to create a class. You already know about the main function. Now, what we're doing here, we can use car because we imported it. Again, just to demonstrate, if I remove car, this is going to be like, dude, what the hell? I don't know what car is. We have to import it, otherwise it doesn't know what a car is. All right. And then we're creating a new variable called myNewCar. Its data type is a car. And then we're saying create a new car object, calling the car's constructor, and giving it a parameter with a value of 4. So then in our car class, we have our constructor method here. We can access it in our main class because its access modifier is public, which means we can call the constructor from anywhere. We can create a car object from anywhere in any code. And we give it count wheels as 4. So based on what's happening in this constructor, num wheels gets set to 4. Okay. Questions about that so far? Cool. So now my new car has a property, num wheels, and that property's value is 4. Now what I can do, given this, we can take that object, that car object stored inside my new car, we can do my new car, and we can call its drive function, if I could type. It's complaining to me because I did not set drive to public. So this is a change you're gonna make. In your car class, void drive, I forgot to add the public modifier. Okay. So now by changing it to public, the main class is able to see this function and is able to execute it. Okay, has everyone got this typed out so far? Cool. Now let's run our code. I believe this will work. Next to the main function on the left side, in Intellij, you should see a green arrow. In Eclipse, I'm not sure what you'll see. So if you don't know how to run an Eclipse, you'll need to show me your screen and we can figure it out together. But to demonstrate on Intellij, if I click this green arrow and click run main.main, Intellij will compile the Java file for me and then run the class file for me, all in one step. And you'll see it prints out, I'm driving on 4 wheels. Because my new car, num wheels was set to 4. And then in our drive function, we're doing system.out.println, I'm driving on this object's number of wheels. And then the text wheels. Does that make sense to everyone? Oh, cool. Because that's like the big leap. Huh? What's up? Yes. So if we do not put this public, public is an access modifier, and it basically says that other classes outside of this class can see and use this method. If we don't add public, it's a type of access called package private, which I have not covered in this class because I'm only worrying about 2. There's 4 access modifiers total. I'm only teaching 2 of them for now, public and private. If we set this to private, it means you can only use this drive method inside the same class. And so our main class is not the same class as our car class. They are 2 separate classes. And so main class, you'll see this red squigglies under drive. It says drive has private access in the car class. So the main class is unable to see it. However, if we change the modifier to public, now the main class basically has permissions to see and use the drive function in the car class or a car object. Does that answer your question? Does that make sense? Great. Does anyone else? Yeah, no problem. Does anyone else have questions about that so far? Cool. Does anyone else need help? You Eclipse folks, do you guys need help running it, or did you figure out how to run it in Eclipse? Cool. Bobonazar? Cool. And Mohammed, did you get yours to run too? I'm going to take that silence as a yes. And if not, you can tell me later and we can fix it. Cool. So that kind of demonstrates my new car. Now, let's, just as a demonstration, let's do another car, dot drive, right? Same method, different object. Now, because these objects come from the same class, they both have this method. And the method is going to do the same thing, but the data stored in each class is different. So the output will be slightly different. If you run it now, who can tell me what they think will print out? No problem. So we have this my new car, and we're calling its drive function, its drive method, right? And then later on another car, which is a different separate object, we're calling that object's drive function. Given what the drive function does, can you tell me if I run this function again, now that I've added this line, can you tell me what will be printed out? Correct. So let's demonstrate. It's compiling, it's running, and yes, you're absolutely correct, Catherine. Do you folks understand that? Does it make sense? Do you have questions? Cool. The rest of you guys? Whoa. Okay. Whew. Cool. So far, so good. So that's kind of the basic object stuff, but I know I get the impression that maybe getters and setters weren't clear to you guys. So I want to do a little bit of some strange stuff here. In our getNumWheels function, in our car class, I want to add some code. I want to add system.out.println getNumWheels was called. Okay, I want you guys to add that. Let me know when you have that added. We're doing good on time. It's going to be a little bit tight, but I think we'll be okay. Great. And the rest of you folks? Cool. All right. And Kasan and Bobonazar? Man, yeah. Good. Okay, great. So now what I want you guys to do is after third car in our main class, let's define a new variable. Let's call it third car wheels. Third, I should learn to type. And let's set it equal to third car dot get num wheels. Oh, let me make this a little bit wider for you. And then just for demonstration purposes, I want you to do system.out.println third car. Why can't I type that? Third car wheels. Now I understand this code is kind of nonsense. It's not terribly useful, but I just want to demonstrate how things are working. Okay, so let me know when you guys have this typed out, and then we're going to test things and we're going to play with it. Okay. So again, let me know when you guys are finished. Great. And everyone else? Cool. All right. Yeah. Mm. So mhm. It will get it actually won't even compile. It will give it'll give an error when you try to compile it. So I just wrote this example line here. Don't write line 14. Um, you'll see I did third car.numWheels. You'll see that numWheels is red. If I mouse over it, it says numWheels has private access. Okay, so I can't access it in a different class. So to directly answer your question, yes, it will give an error. Does that make sense? Great. Okay, great. So now if we run this, you'll see what happens is, because we used get numWheels instead of editing numWheels directly, it gives us an opportunity to run some extra code. In this case, the extra code we're doing is printing out that this function was called. Okay. Now that can be helpful when you're debugging things, like if you have a problem. It can be helpful if you need to, let's say you're doing a high security application and you need to log when certain data is accessed. This is a way you can do that. And doing these, the main purpose of get num wheels is to get the number of wheels, right? However, sometimes we need additional work to be done. And we call this a side effect because it's something that happens that's not the main purpose of the function. Okay, so by using getters, it gives us the opportunity to create side effects like logging things. And that's just one kind of basic, kind of silly example. But there are more complicated examples. Um, for example, maybe if the object is supposed to have the same data as data in a database, yes, it may store the data locally, but maybe you want to go out to the database and double check the value before giving it to the person, right? Um, so that's kind of an example of a side effect. And then, so that prints out first, get num wheels was called prints first. And then, because this is a getter, it outputs an integer, that integer being the number of wheels. We can still, like any other data, store that in some variable and then print that. Does that make sense? A bit ambiguous for you. Can you describe which part isn't clear? If not, I can try to explain it in a different way. Mm, okay, I see what you're saying. So when we create this third car wheels variable, uh, to get the value that we're going to store in it, we call third cars get num wheels function or method, right? And that goes out and that executes this method. Within this method, we're printing out this. So when this gets executed, this happens. Okay, so it's almost as if we had it like this. And then after this gets printed, then numWheels is output and it gets set to the variable. Does that make sense, or it's still not clear? Okay. So I guess okay. Let me try explaining it in one more way to see if it's a little bit clearer. So if I instead wrote this line like now this code is not correct because of the private accessor. However, these two things, so this line that I have commented out here and these three lines are effectively the same thing. Because what happens in line 14 here is I create a new variable called third car wheels, and I say it's going to store an integer. Then the next thing I do is I say, hey, run the third car objects get numWheels method. So once I do this, what happens is this file, this main class, pauses. And then because I called this function, main.java basically pauses, and then it goes to the get numWheels function and it runs whatever code is here. And that code includes printing out this log entry and then outputting the numWheels. So then once this finishes, then it goes back to main.java. And then it takes the numWheels that was output by the get numWheels function and gives it to this third car wheels. Basically the same thing as what I've written here. Is that a little bit clearer? Okay, cool. If it's still not clear, please tell me and I can describe it in a third way. Okay, cool. All right, so I'm gonna get rid of this. So basically, and that's kind of that's a fundamental thing with functions that some people have some difficulty understanding. Is when you execute a function, barring some crazy fancy threading stuff, in 90% of cases, when you execute a function, wherever that function call, basically this part that I've highlighted here, wherever that happens, it pauses. And then it goes to the function definition and runs the code inside. And then once it finishes, it goes back and it continues. This is true of all functions, unless you're doing futures and threads and stuff, which we're not covering. Okay? And that's just to everyone, because that's something that, it's something about functions that some people have trouble understanding. Yeah. So, and that can be a little bit confusing because what happens is the code execution path is actually jumping around between different files, and it can be a bit of a mess to understand at first. But as you get more programming experience, that will become more natural to understand. But I'm glad you asked that question because that's a very important point to understand. And we're doing good on time. So that's kind of an example of using a getter and having a side effect. Let's do the same thing with a setter. Okay? Or I'm sorry, before that, does anyone have any other questions before I move on to that? All right, so let's do an example of a side effect with a setter. Remember earlier how I was talking about having an odd number of wheels is no good? Let's go ahead and set that up. So in our setNumWheels function, because again, you don't want to have a car with 3 wheels. I mean, I guess technically that's possible, but we're not being fancy here, right? We don't have fancy futuristic cars. So what we're going to do is we want to check if numWheels is an odd number. And if it does, we want to complain and we want to break everything. So we're going to do that. Now, we're going to throw an error here. You guys have not yet learned about throwing errors, okay? And I have not taught it yet. I'm going to teach it later. I just want to use it as an example for now, okay? So we're going to check if numWheels, given as an input, right? Because numWheels here is different from this.numWheels. They have the same name, but they're 2 different things. I want to check if this is evenly divisible into 2, right? In the case that it's not, this is basically checking if it's an odd number. I want to throw new exception, sorry, new runtime exception. Runtime exception. Can't use an odd number of wheels. And let me. Okay, so I want you guys to get lines 16 through 18 added. Okay, and let me know when you guys have that typed out. And don't worry about the meaning of line 17 right now. We have not covered that yet. I'm just using it as a demonstration. I guess I could have done it differently, but it's already written like this. And if you guys have trouble typing this or anything, please let me know. Great. All right. 2 out of 4. 3 out of 4. All right. So now, again, this is saying that if we try to do setNumWheels with an odd number of wheels, it's going to break. So back in our main class, at the end here, let's add some new stuff. Let's try thirdCar.setNumWheels as 3. So I want everyone to type this out, and then I want you to try running it. I just want you guys to see what happens. Yep. Perfect. And that's exactly what we expect to see, right? We say, hey, the program is breaking, you can't use an odd number of wheels. So this is actually a kind of more real world-ish example where you can use a setter to prevent another programmer from setting an incorrect value for your object. And this is something you would do in real life. Okay. However, if we set this to 4 instead of 3, we run it, you would expect to see no problems. There you go. And just for kicks, let's add thirdCar.drive at the end, because why not? So does everyone understand? Well, why is this complaining that it wasn't used? What do you mean was never used? Are you high? Oh no, that was weird. Just slow to update. Cool. So does anyone have any questions about this so far? Or not so far, I guess we're pretty much towards the end. Cool. So to review what we covered today, we went over what the difference between a class and an object is. We explained what a constructor is and what you can do with it. We went over properties and methods. We talked about access modifiers and how to control what other people can and can't access on our objects and classes. We talked about packages, basically how to organize our code and then how to import our code. And we did some examples of using getters and setters and how we can use side effects to help our code operate better. So if you guys managed to understand most of this, even a little bit, great job, because this stuff is complicated. And we actually covered a lot pretty quickly. That's a lot of material in 2 hours. So I just want to make sure, does anyone have any general questions about what we've covered today before we tie things up and end things? Please ask. Mm-hmm. Ah. Okay, so that is a good question because it means I did not explain things properly. So thank you for asking. This does not hide any of your code. If you post this code on GitHub, everyone can still see all of it. What this means is it kind of forces, if another developer uses your code, it forces them to work a certain way. For example, if I want to access thirdcar.numWheels, because it's private, it won't let me. And that instead forces me to use the getNumWheels getter or the setNumWheels setter. And it allows, basically it forces the user to have to deal with these side effects. The user, the other developer to do these side effects. So it's not necessarily a public-private in terms of like hiding your code. It's more of forcing either yourself or another developer to access things in a certain way. Does that make sense, or is that not quite? Correct, you got it. Yep. Now, theoretically, if another developer just downloads your code, they could just change this to public, right? Like, oh, that was hard. But one, most people won't do this. They're not going to edit someone else's code unless they're actually working with you on the project, although you shouldn't rely on that. But secondly, doing this is kind of a signal to the other developer, like, you shouldn't mess with this directly, right? You shouldn't I have marked this as private because I'm saying there is a proper way to do this, and editing it directly is not the proper way. Okay. So it's not like when I say forcing, um, maybe forcing wasn't the right word. I apologize. It's more like guiding in a forceful manner. Does hmm. It is basically telling another developer, you don't want to mess with this directly. I've made a different way for you to access it, and you should use that way. It's kind of a guidance. Okay. But what you said previously makes sense. Is accurate. Cool. Now, some people might say that um, this is actually not a good time to teach access modifiers, not a good time to teach public and private, because we're only using a part of them, and it's hard to understand why you would want to use them. When we do when we do our next lesson, um, 1 week from today, you'll see more of how and why we should be using access modifiers. So, yeah. Does anyone have any other questions? Yes. Yep. Yep. Absolutely right. And that's I was trying to be like, hey, just kind of treat this as magic right now because I haven't taught it to you yet, but now you have learned it. So, yep. Um, so to fill everyone else in, last week we did a class where we created a text-based calculator. Um, and Java has a built-in class called a scanner, and that allows you to read in stuff typed from the user, like the person actually running your Java application. And we use that to collect the input from the user of like 4 plus 6 sort of thing. Um, and in that way, or we had to use the Java scanner and create an object from it and all that, and use its methods and all that kind of stuff. We did that last week, but I didn't really explain why because we hadn't learned objects yet. But now, yeah, excellent. Any other questions from anyone? Yes. Right. So the constructor is automatically called when we create the object. So if you look at the main class here on line 7, when we create a new car, it executes the constructor. If we did not have this in the car class, if we did not, if we did not have this line 7 of the car class, num wheels would default to 0, right? But by doing it this way, we're saying that, hey, when you create a new car, you have to tell me how many wheels to get it, and then we're going to set it the number of wheels, and we're going to save it. The set wheels setter basically allows us to change that later. However, we could do, to your point, we could instead do something like this, and that would kind of be the same thing. Now, we actually kind of have a problem here. In the real world, we would have a bug because we're checking if the number of wheels is odd only in the setter. We should be doing this in the constructor too. Let me go, but we just added it later. That's the only reason it's not there. In the real world, this would be considered a bug. This logic here should also be here, but whatever. Cool. Yes, that is correct. The constructor is used to set the initial value. Absolutely correct. Yep. Other questions? Using overloading, yes. So for example, we could do public car, cat car, with no parameters, and then we could set this dot num wheels equals some default value of 4. And in this way, we have 2 constructor methods, and you can do either one. And that's just normal method overloading. You can do, or normal function overloading. You can do that with any function, as long as the parameters are different. It's a good question. It's whichever one they decide to use. So if I do car fourth car, and I do new car, and I don't provide any parameters, it's going to use this one. If I do provide a parameter, it will use this one. Yeah. So if I do something like this, it won't let me. The parameters have to be different. Now, if I did something like this, right, it's a different type of parameter, a different data type. And then I did something like typecasting here, which I haven't really taught typecasting, and we're going to cover that, I believe, in next class. This would work because the parameters are different. So as long as the parameters are different, the function name, whether it's a constructor or another function, you can have as many copies of it as you want as long as the parameters are different. And that's called method overloading or function overloading. Arguments, parameters, yes. You can also change the number of parameters. For example, if I do int count wheels, and then, whoa. And then in addition to that, I do int some other number, right? This is also, why is it still complaining? Come on, update, update. Weird. Okay, I don't know why it's not updating. If we can have the same type of the first parameter, but if we have a second parameter, then it's a different method. It's another overloaded method. And then if I do car fifth car equals new car 1 2, that would call this one here. So what Java is going to do is when it receives a method, first it's going to check the method name, all right? And it's going to be like, oh crap, there's 4 different car constructors. Then it's going to look at the parameters and it's going to say, okay, this one has 2 integers. Ah, okay, this one has 2 integers, so I'm going to execute this one. Does that make great? And again, when tests or job interviews come along, this is called method overloading. You're overloading it with more types of inputs. No problem. Any other questions?
Cool. All right. Well, great job, everyone, because this stuff is hard. When you're first learning it, as you get more practice in programming, you won't even be thinking about this sort of stuff. You'll just be doing it. These will just be tools in your toolkit. And you're going to be like, oh, I'm going to use a hammer now because I'm hammering a nail. And then you're going to be like, oh, this is a screw. I'm going to use a screwdriver for it. You're just going to use the right tool for the job. It will take time to get to that point where you're not thinking about, crap, what is that thing I need to do here? It's going to take time for you to get comfortable and to be able to think of these things automatically. But you will get there. It just takes time and effort. So, given that, homework. Um, for those of you who are joining this class for the first time, this is a free class. It's not like I'm going to kick you out of the class. It's not like I'm giving you a grade or anything. This is just for your practice. I do recommend you do it because we do these classes only one time per week. We only do them on Sundays. And a week is a long time, and you're going to forget a lot of stuff in a week. So I recommend that you do this on like Wednesday or Thursday, kind of in the middle of the week, to refresh your memory. So here are the instructions to kind of, and these are super detailed, right? To guiding you step by step on what you should do. But to summarize, I'm asking you to create some packages and create a song class with a few different properties, and asking you to set up getters and setters for those properties, and then asking you to create song objects from that class and use their getters and setters and do printing and stuff like that. Okay, it's basically it's very similar to what we did today in terms of the type of actions. It's just that the content is a little bit different. Okay. So I recommend that you folks do this on Wednesday or Thursday, or sometime in the middle of the week. Again, just to refresh your memory, just because that will help you learn. And then additionally, we already covered questions. I should probably move that earlier into the presentation. If you have more questions, or you forget things, or you have trouble, you can always message us on Discord, which is in this presentation and which I will send out. But I'm sending out this presentation to you guys as well. There are links here to other tutorials on the same content that we learned today. Okay, so if something maybe didn't make sense, or you just want to see things explained in a different way, you can do so by visiting these links. And lastly, uh, thank you for coming. Again, we are CodeSeoul. We are a nonprofit organization. So we don't make money from this. All of our events are free. If you want to donate, that would be awesome. And there is donation information in the presentation here. If you don't want to, that's totally cool. If you're a student, you probably shouldn't donate. You should probably save your money. And our donations are not yet tax deductible because we are still just a phase 1 nonprofit organization. So yes, I'm going to share the slides in just a second. So that covers it for today. Well, thank you everyone for coming. Again, our next class is going to be the same time and day next week. We will be covering Java collections and inheritance, so more object-y stuff. So again, thanks for coming, and looking forward to seeing you guys again. Bye-bye.